This is a demonstration corridor of connected vehicles here in Washington, D.C. that we've put up.
Speeding in school zone.
There's a school zone here, and you can see that even though we as a driver, we missed the signs of the school zone, it alerted us that there was a school zone, that we were speeding because there are children getting on and off the buses. Up ahead here, there's a traffic light. And the interesting thing about this traffic light is it's obscured by the trees.
Speeding in work zone.
And so what the connected vehicle technology connects these traffic lights to the app in your car, or to your phone, or to your car in the future. Here's another traffic light ahead at Brentwood and New York Avenue, and you can see that this is red ahead. And even though the traffic light is completely obscured to us, the car still knows the state of the traffic light and can adjust its speed and so forth, and deliver all kinds of applications. These include safety applications like red light running, preventing you from running a red light, as well as convenience applications like getting ready for green, which is when the light's about to turn green, it'll give you an alert. And as we drive down this corridor, we'll see some of this in action. This corridor is fitted with both cellular V2X as well as cellular V2N technology, which allows for both radio technologies to be tested. Our partners Comsignia provide the cellular V2X technology, and Applied Information provided the cellular V2N technology. Again, we cruise down here and you can see one after the other the status of the traffic lights is accurately reflected on the phone. What we're going to do is change lanes here, and again illustrate the purpose of this is behind this truck. You've got no visibility of the lights at all. This is Fenwick over here, and we're going to turn right on Fenwick, and we'll see. Oh, in fact, here we've got the lights changing to red in front of us. It's going to turn right on red here, but this will illustrate when you approach from the side street that the one will get a red light, and if there's no traffic, we can simulate a red light running alarm. But if there's traffic, which there always is in DC, it's just much more difficult to do. Doing a U-turn here so we can approach the side street. Again, approaching from the side street, the phase status of the traffic light ahead is accurately reflected. Again, this is the kind of situation where a distracted driving incident can occur. For example, people checking their text, people becoming distracted by the conversations in the car. And what causes an inefficiency in the transportation network is when people don't notice that the light has changed to green. So giving folks an audible alert that the light is going to change to green will mean that you get increased efficiency of pull-off, because the time is not wasted. And what's called in DC the red light to green light reminder is the person behind you honks at you when the light changes to green and nobody notices.
Get ready for green.
That's an example of the convenience application, get ready for green. And you see these people in front, they pulled off slower than we would have pulled off because they didn't have this app to connect to the traffic lights ahead. This is approaching now 16th Street.
Green.
You can see that the lights ahead is completely obscured by us. We can't see it at all. And yet a future autonomous vehicle, and connected vehicle, can behave safely and sensibly through connected vehicle technologies, because the car always knows the status of the infrastructure that's ahead of us and around us. This is the last intersection in this demo corridor. It was a run of six intersections, and for the first time we're actually seeing the light ahead visibly because of this construction and the nature of the traffic lights in Washington DC, plus the roadworks and so forth. This is our turnaround point, so we'll turn around here and head back. This gives us another opportunity to approach the traffic light from the side street. This particular corridor runs very long cycle lengths, and so from these side streets you can actually wait a long time in order to be serviced with a green light, and that again makes for in times of congestion irritations and difficulty for the person who's waiting at the light, because they don't know when the light is going to change to green. On this corridor as well, there's a number of traffic lights that are obscured by trees, and the red light running alarm will provide additional safety by alerting folks to the fact that there's a red light ahead. There's another interesting aspect to this corridor. This corridor is, for the traffic engineers involved, is equipped with 2070E traffic controllers, and the traffic controllers in fact don't support the signal phase and timing you need to be able to do connected vehicles. What we did at Applied Information, through our knowledge and experience with running preemption systems and emergency vehicles and transit signal priority, is we have the ability to sense directly the status of the green signal in all 8 phases and 4 overlaps.
Get ready for green.
Hold on, the light is about to change. And this is, even though I'm narrating to you, it's convenient to me. I was distracted then, and but was able to pay attention at the right time to the lights ahead. Again, the lights ahead are completely obscured. I can't see them at all from my vantage point, but with the connected vehicle technology, they're certainly made available to the car. So I was explaining that what the connected vehicle technology is that we generate the signal phase and timing, the so-called SPAT data, from our knowledge of the green state, our knowledge of the red clearance interval, and our knowledge of the sequence. So what this means is that you can get effective connected vehicle technology in all 350,000 of the United States traffic controllers without necessarily upgrading the traffic controllers. Yes, the traffic controllers should in time be upgraded to the more advanced features, but it's a chicken and egg situation. You don't want to have the traffic controllers having to be upgraded in order to be able to do connected vehicle. And this corridor certainly demonstrates that you can do a very effective connected vehicle technology without having to upgrade the controllers. Here's an interesting one that you can see that this is the one with the left turn, and it's a protected left turn, so you've got a red arrow and a green through, and that's accurately and informatively connected into the car. You can see ahead, there's a vertical curve here with the green lights obscured, but there's a protected left and a green through on this traffic light ahead, which is still completely obscured. I can't see it at all. It's somewhere up here. In fact, it's buried in the trees, and these lights are in fact obscured by the trees, especially if you're in the lanes that are next to the trees. Again, I was going to do a red light running to get the red light alarm, but the light changed to green just in time. And this that again is the last of the corridors, but over here we've got a simulated work zone. I'm just going to change lanes for my turnaround.
Speeding in work zone.
And you can see that this work zone again provides an audible alert into the car to help keep the workers in the work zone safe, and notifying the
Speeding in work zone.
Notifying the driver in the car that there is a work zone active and their workers are active. As soon as your speed drops below the work zone, then the alert goes away. Well, that's connected vehicles in Washington, D.C., showing one, that you can do connected vehicles without the traffic signal controllers doing signal phasing and timing. You can actually do it with the what's called the RSU processor, roadside unit processor, that interprets what's happening on the traffic intersections and provides sensible signal phase and timing data. You can see you can do red light protection for the motor cars even when the traffic lights are obscured by trees and so forth, which they are in this instance. You can see you can do a convenience application, get ready for green, improve the response of the cars who are waiting at the light. You can also do air quality improvement by turning off the engine of the car when you're stuck at a red light, because then you know that you only have a few seconds before the lights turn green, and then you can start the engine again. It's auto engine start and stop. And then finally we have the kind of work zones and school zones, which we can communicate information to the motor car about reduced speed in difficult and dangerous situations where a lot of traffic accidents occur.